Hello dear students, I am Jayant Mane from Finolex Academy Ratnagiri, and this is the fourth lecture of drives and control. Today we are going to see status of AC and DC drives. Status means what is currently the share in applications, industrial applications of AC drives and DC drives, how much AC drives are used, how much DC drives are used, and all that. What are the technologies, what are the advantages of individual type of drive and all that. Okay, so the first point is regarding induction and synchronous motors. So induction and synchronous motors, that is AC drives, were used only for constant speed applications. And in variable speed applications, DC drives were dominant. So this is the old picture. In olden days this was there because controlling AC motors was not that much easy with some conventional you can say elements like resistors and some transformers. So if those methods are used in AC motors, the range of the speed control is not that much and precision is also not there, whereas if DC drives are used, in that case using some resistor, some potential divider or like that, speed can be easily controlled. So DC drives were having upper hand, and even they are very suitable for high power applications. So that is also, you can say, one of the advantage. So we are obviously talking about industrial applications. So this was old picture, but when thyristor technology started evolving, so that has started improving the performance of drives, both AC as well as DC drives. So this has changed the use of drives in industries. So thyristors means some power electronic converters. Those are highly efficient, and again yet they give very good performance. Obviously cost and all that is involved, but this is very good technology. It has improved the performance as well as the efficiency and all that by, you can say, tremendous amount. This has changed the picture of whole industry. Then although induction motors were cheaper than DC motors and their control circuit was also cheaper in induction motors, but their speed range was less. So obviously they were being used by very small amount in industries. Then while AC drives also were not reliable as DC drives, so DC drives were very reliable, but then the development of this then the development of VLSI based circuits, in some development of some ICs. So they have improved the performance of power converters and obviously performance of AC drives to very high level. And then the AC drives started gaining the share in the application. So already the AC motors are having very good advantage from construction point of view over DC motors. So they are consist of very less number of parts. Just compare any DC motor with squirrel cage induction motor. In squirrel cage induction motor, there is just a stator having 3-phase winding, and rotor is a short circuited cage. That simple it is. Whereas in case of DC motor, there is commutator, brush, and all that sparkings, wear and tear of the commutator, so many problems. So constructionally, induction motor is advantageous over DC motor. Its power to weight ratio is also high. Due to less number of components, its weight is less for driving some particular amount of load. So that is called as power to weight ratio. In other words, if I can give you some example, if some person having weight of 50 kgs, and if he can lift 75 kgs, then there is another person of 75 kg of weight and it can lift 75 kgs, then power to weight ratio or strength of the first person is higher. He is weighing 50 kgs, still is able to lift 75 kgs, whereas the another person can lift 75 kgs and his weight is also 75 kgs. In that case, power to weight ratio is less. He is not as strong as the 50 kg person. So it's like that. So power to weight ratio is very important in some applications, especially some aviation, marine applications or electric vehicle applications, wherein if if weight of drive is very high, in that case it could be able to carry very small amount of load, number of persons or goods, like that, in the vehicle. So power to weight ratio is very important. So the AC motors are advantageous from constructional point of view. Just the problem was the control point of view. But due to improvements in power electronics, nowadays there are again new techniques like vector control and direct torque control in industries. So due to development of these technologies, now the AC drives also can be controlled just like DC drives. So they are giving very good performance. So they are gaining popularity and their applications are being continuously increased. Even you can see the Mumbai local trains. Previously it was a DC system. Right now it is AC system. So this change is happening everywhere. But still, the DC is not completely replaced by AC. There are some applications wherein, especially very high power applications, wherein the converters are costly. So for driving AC motor, we need converters, and the cost could be very high. So in that case, DC drives are still being used in some of the applications. So even though the technology is very good, but there are some other parameters like cost and size and all that, wear and tear or capital cost. So all that one should consider, isn't it? Again, there are some special machines like brushless DC motor and switch reluctance motor. There are so many again new types of motors coming in. So it is not nowadays just a DC drive and AC drive. There could be some special drives, and those are also gaining popularity in low and medium power applications currently. Afterwards, if the technology improves, they may also enter into this high power drives technology. And again, these AC drives also could be replaced by some special machines and all that. We may see that change. That depends upon the development in this region, in this area of power electronics and drives. So this was about the current status of AC and DC drives. in industries. Next lecture will be the fundamental torque equation.